Hi guys, Assalamualaikum. Okay, today I want to we want to discuss about vertex cover. This is one of the topic in graph theory in matching. Okay, so what is a vertex cover? A vertex cover of a graph G is a set of Q subsets to vertex G that contains at least one endpoint. Okay, remember one endpoint of every, okay, one endpoint. So cover one endpoint of every edge. So remember, vertex cover of a graph G is a set of Q subset to VG that contains at least one endpoint of every edge. Then the vertices in Q cover every edge. Okay? So let's see here. We have, okay, let's say we have vertex A, vertex B, vertex C, vertex D, E, and F. Okay, if we see for the vertex A, okay, vertex A only cover the edges of AD. Only edges of AD. The vertex A cover. Okay, for vertex B cover only BD. Okay, only edges of BD. Okay, let's see vertex C. Okay, vertex C, this is vertex C, cover edges CD, CE, and CF. Okay, so vertex C cover CD, CE, and CF. Okay? Alright, and what about vertex D? Okay, vertex D cover, okay, A, B, and C. So AD, BD, and CD. What about vertex D? Vertex E. Vertex E cover of what? Okay, I left it for you to find what is covered by vertex E and vertex F. Alright? I hope you have understand for these parts. Okay, let's see. In a graph that represents a road network, let's say this is a road network, we want to find a minimum vertex cover. Okay, a minimum vertex cover. What is the minimum vertex cover? So we want to find a minimum vertex cover. Minimum vertex cover means that we want to placing the minimum number. Let's say we want to placing the minimum number of policemen to guard the entire road network. So this is called minimum vertex cover. The minimum number of the road. Of the minimum number of the road means the minimum number of the edges. Okay, so minimum vertex cover, okay, equals to is the minimum number of edges covered by the entire road. Okay, let's see here. Let's say we want to find the minimum policeman that can cover all the roads. Okay, let's say the edges is the road and the vertices, which vertices you want to put the policeman so that it will cover all the roads. Okay, so here, Okay, we have A, B, C, D, E, F. Alright. Okay. So, if we have said just now, if you take A, if you put the policeman at A, so you only will cover the road for A and D. If you put the policeman in F, you only will cover the road of C and D. And if you put here at E, you only will cover this road. So there are many policemen you have to put on. Alright, only this road, and means that you have 5 policemen to cover it. But how you want to cover all the others? Okay, you want to find the minimum policeman that will cover all the roads. Where is the best place? Okay, so let's say if we put here at D and C, okay, D, if you put the policeman at D, you will cover A, B and C. Okay, if you put at C, you will cover C, E and F. So means that you have only 1 and 2. Only 2 policemen. Okay, so what is the minimum vertex cover for this to cover the road? So the minimum vertex cover, okay, so the minimum vertex, okay, we put in other ni. So what is the minimum? So minimum vertex cover is equals to, okay, this is A, B, C, D, E, F. So the minimum vertex cover just now is at C and D. So the minimum vertex cover is C and D. What is the number of minimum vertex cover? The number of minimum vertex cover is equals to 2. Okay? So this is the vertex cover, the number of minimum vertex cover of 2. So you have to find the vertex cover. The minimum vertex cover means that you have to find that the minimum vertex that will cover all the edges. Okay? Alright. Okay. Okay. How can we find matchings and vertex cover? So you must know that for this underneath graph, okay, mark of vertex cover of size 2 and show a matching of size 2 in bold. Okay, vertex cover, okay, so what is the relationship between vertex cover and matching? Okay, vertex cover must be greater or equal than number of matching. This is number of vertex cover, number of vertex cover. This is greater or equal than number of matching. So let's see here. for just now, you know that what is the number of vertex cover. Okay, so just now you know that number of vertex cover equals to 2. And now if you find the matching number, so this is matching. Okay, so matching number of matching also equals to 2. So here, so that 2 is greater or equal than 2. So this is proof that number of matching must greater or equal than number of vertex cover must greater or equal than number of matching. Okay? Okay. Let's see this matching and try to find the matching and the vertex cover for this graph. Okay, if we see here, how many vertex cover are there? Okay, let's say we have A, B, C, D, and E. Where is your vertex cover? What is your vertex cover? So vertex cover here means that you want to find the minimum vertex cover. Okay, so minimum vertex cover. So minimum vertex cover is, you can choose. Okay, let's say I choose okay, let's say I choose E. So I can, E means that E discover EA and ED. Okay, and then I choose C. So C will cover CD and CB. So we have one more to choose. Let's say I choose B. B cover this one. So all the edges are covered. Are there more? So means that we have 3 numbers of vertex cover. So are there can be small than 3 of the vertex cover? Can you find whether the vertex cover is less than 3? So if we see, you can try. We only have 3 vertex cover. If you take A, okay, let's say you take A as your vertex cover, so we'll cover here and here. And if you take D, we'll cover ED and EC. So one more of BC is not covered yet, so you must take one more B. So there is still also 3 numbers of vertex cover. So we can say that whether A, B, D, okay, is the minimum vertex cover, and the number of vertex cover equals to 3. Okay, the number of vertex cover equals to 3. How about matching? Okay, you have find the minimum vertex cover. So now we want to find the matching. Okay, so let's see matching. So how to find the matching of the graph? Okay, we have to wrap this first. Okay, just now we have, this is okay, BC. Okay, so matching, you have to find that the where the edges that where the edges cannot you cannot share the edges. You cannot share the same vertices, the edges that cannot share the same vertices. So the maximum matching is, if you put here is the matching A, B and C, so the matching is cannot be at C, D or A, B, but you can match at A. So E, D cannot match already. So you have number of matching number, okay, matching number equals to 2. Okay, so just now we know that number of vertex cover, okay, number of vertex cover must be greater or equal. Okay, number of vertex cover must be greater or equal than number of matching. So if you see here 3 is greater or equal than 2, so it is proved. Okay, it is verified. Alright, so this is matching and vertex cover. Okay, so that's all for vertex cover. Hopes that you will understand and continue with other exercise. Okay, see you. Assalamualaikum.